There exists a unique triple point at 273 kelvins and pressure of 611 newtons per meter squared, at which all three phases can coexist. Note that ice is stable only at T less than TTP, and liquid water is stable only at P greater than PTP. At low pressures, water goes straight from the solid state to the gaseous state at the temperature increases. In other words, it sublimes. Right, that makes sense. At low pressures, water goes straight from the solid state to the gaseous state. As the temperature increases, in other words, it sublimes. Also shows average surface temperatures and pressures on the terrestrial planets with atmospheres. Venus is too hot for liquid water to exist. So it's so close to the sun. Hi, Ella. Venus is too hot for liquid water to exist. Mars, on average, is too cool for liquid water to exist. It was only in the warmest, highest pressure regions of Mars that liquid water flowed in the past. However, the average temperature and pressure on Earth has been close to the triple point for much of the planet's history, meaning that gaseous, liquid, and solid water could all exist in significant quantities near the Earth's surface. Astronomers, thinking back to the stories of their childhood, sometimes refer to the Goldilocks effect. Venus is too hot for liquid water. Mars is too cold, but the Earth is just right. The clouds of Venus are transparent to radio waves. Thus, the Magellan spacecraft was able to map the surface of Venus using radar. The resulting radar image of Venus is shown. I'll show it to you. Most of Venus consists of low rolling plains. Wow. Like Vermont, I think, I don't know. But there are two prominent highland regions, Ishtar Terra, about the size of Australia, and Aphrodite Terra, about the size of Africa. So these are the regions of Venus. Most of Venus consists of low rolling plains, but there are two prominent highland regions, Ishtar Terra, about the size of Australia, and Aphrodite Terra, about the size of Africa. Venus has many volcanoes and extensive lava flows on its surface. The average age of the crust on Venus is roughly 0.5 gigayears, indicating that the surface has been extensively repaved by lava during the last billion years. Venus has relatively few impact craters. Magellan saw only 1,000 of them, more than 100 meters across. The scarcity of craters is partially due to the thick atmosphere of Venus. Small objects break up in the atmosphere and are vaporized, lol, and partly due to the relatively recent lava flows. So partly because small objects will break up in the atmosphere and are vaporized. Remember, we talked about the vaporization even within the crust, and partly due to the relatively recent lava flows. There's no evidence for plate tectonics on Venus, no rift zones or subduction zones, for instance. The volcanoes of Venus are spread evenly across the planet's surface instead of being concentrated at plate boundaries, as they are on Earth. Because of the lack of plate tectonics, the lithosphere of Venus remains stationary